Thank you, thank you. Okay, so these are the list of chemicals produced in billions of kilograms in US, So we have here sulfuric acid. So ito yung pinaka widely used chemical sa industry, Ammonia. Well, why are we producing so much ammonia? Kasi ginagamit yan sa production ng fertilizer. Ethylene. Saan naman ginagamit ang ethylene? Sa plastics, Propylene, plastics din yan. Ethylene, propylene, plastics yan. Phosphoric acid, fertilizer din yan. Kamukha ng ammonia. Chlorine, bleach. No? Di ba? Bumibili ba kayong Sunrox? Yun, lalo na ngayon, maraming kailangan maglinis ng bahay, maglampaso ng bahay, O chlorinic acid, di ba? Nitric acid. Ano ba ginagamit ng nitric acid? Urea. Urea is a fertilizer, Benzene. Benzene solvent yan. Methanol, I really don't know. Pero probably sa paints, Ethanol, siyempre alam niyo naman ethanol kung saan ginagamit, disinfectant. Ethylene glycol, so it is widely used in US probably. Ano yan, coolant. Sa atin coolant yan, pero sa kanila anti-freeze yan. So kasi pag winter, pag hindi mo nilagyan yung tubig, yung nakalagay sa radiator, it will become ice, It will freeze. So kaya yan, necessary sa kanila yung ethylene glycol. Sa Philippines naman, hindi naman nangyayari yun. So ang gamit natin sa ethylene glycol, lang, coolant. Actually, pwede mo namang hindi lagyan yung tubig, Pero sa kanila, malaking commodity yung ethylene glycol. Okay? So bakit ba mention to? Why do they mention this? Why do the book mention this? Kasi most of this is produced from chemical reaction. Wala ka namang makukuha in nature na sulfuric acid, wala ka namang makukuha in nature na na ammonia. Parang gano'n, you need to produce this in using chemical reactions. So that is why we are discussing this topic, chemical equilibria. Ano ba yung chemical equilibria? When you say a chemical reaction is in equilibrium, ano nangyayari? Ano nangyayari? Kian, ano nangyayari when you say that the chemical reaction is in equilibrium? Anong meron? Anong nagiging constant? Anong constant na? Constant na ba ang temperature? Constant na ba ang pressure? O constant na yung concentrations? Kian, anong constant na? Forward, backward reaction ko. Pwede naman, kaya lang wala sa choices ko kailan. Ang choices is concentration, pressure, temperature. Okay, very good, Pio. Constant na yung concentration pag mayroong chemical equilibrium. Yun yung tandaan niya. Yun kasi pag tama naman yung forward at saka backward reaction, hindi naman constant, equal sila, equal na sila. So in effect, constant na yung concentration. Kasi yung pag sinabi mong constant na yung concentration, hindi mo naman ma-measure yon. Actually, na-measure natin yung concentration. So we know that the chemical reaction is in equilibrium pag merong constant concentrations, ng mga chemical species involved. Okay. So yung mga nabanggit nating chemicals kanina, hindi nyo naman nakikita sa bahay nyo, Saka kahit naman pumunta kayo sa SM, wala kayong nakikitang ganon, di ba? Wala kayong nakikita mga sulfuric acid, ethylene, di ba? Propylene, wala naman kayo nakikitang mga ganon sa mall o kaya sa mga groceries, So actually yung mga chemicals na yon, they are the raw materials for the production of several end-user products like paints, detergents, yan. Di ba? Linggo-linggo, pag nag-grocery yung parents nyo, bumibili kayo ng panlaba, sabong panlaba, di ba? So, yan, detergents. So this is one of the products that uses, halimbawa, na ginagamit dyan. Cleaner alkyl benzene, Tapos nire-react siya sa sulfur trioxide, no? So we can say pwedeng sulfuric acid, di ba? Pwedeng sulfuric acid and detergents. Plastics. So plastics, ethylene, propylene, ano? Di ba? Na meron kayong PE. Nagano na ba kayo CPI na? PE, PP, no? Polypropylene, di ba? So paper. Marunong ba kayong gumawa ng papel? Naabutan niyo pa ba ang industrial chemistry lab? Ba gumagawa ng papel doon? Basically, sodium hydroxide lang ilalagyan lang yung mga damo. Tapos pinapainit, pinapakulo. So matutunaw yung damo and then matutunaw din yung mga lignins, di ba, ng sodium hydroxide. Tapos magdidikit-dikit yung natira and then you have the paper. Pero hindi naman kamukha ng papel. Nakapag industrial lab ba kayo? Kapag industrial lab ba kayo, yung batch nyo, yung of course, hindi alam ko 2020 nagkaroon ng pandemic 2019, hindi baka hindi pa or wala na rin yun, wala na rin industrial chem. Meron pa ba kayo sa curriculum yung industrial chem? Lab? Wala na. So, hindi na kayo gumagawa ng papel sa lab. Anyway, basically ganun lang naman yun. Di ba? Hindi ko lang sa nung high school nyo. Kukuha lang kayo ng mga damo, you need source of fiber. So pwedeng sa labas, yung sa industry, ang ginagamit nila, trees, o logs. Tapos tinutunaw lamang yun. So tinutunaw lang sa chemical. Yung basta may ginagamit silang combination ng sulfuric acid and some other chemicals, Tapos you're going to produce paper. High temperature pati. And then of course fertilizer. So fertilizer, phosphoric acid, ammonia, urea, fertilizer 'yon, NPK. Okay? So, of course, itong mga ito naman, usually compounding lang yan, pinaghahalo-halo lang, Pero may mga reaction din, plastic polymerization, so may reaction din, So, kailangan nyo rin dito ng chemical equilibrium. Pag sinabing compounding, pinaghahalo-halo lang. Okay, so, ito yun, ito yung specific example, SO2 to SO3. So, common, this is a very common reaction kasi everyday ginagamit natin ang sabon, ginagamit natin ang detergent, So yung ang major reactant pag naggagawa ng detergent, yung linear alkyl benzene. Yung linear alkyl benzene generally pinoproduce from crude oil. Pero dumadating yan dito, linear alkyl benzene, lab na yan, LAB, linear alkyl benzene. Na-imagine niyo naman, linear siya, meron siyang nakakabit na chain na alkane. Alam niyo naman alkane CH3, CH2, CH2, CH2 ganun. Hindi specified kung gaano kahaba. Tapos nakakabit siya sa linear alkyl benzene. Sa benzene, Ang benzene alam niyo naman yung piatos, So nakakabit yan doon. So that's one of the raw material of detergent, yung linear alkyl benzene. Tapos basically i-react lang yun sa sulfur trioxide. Sulfur trioxide is SO3. Pero syempre wala naman kayong SO3 sa planta kasi gas yan. So generally pinoproduce ng planta yung SO3 from sulfur. So meron nakatambak yung sulfur dun sa ground, kaya dun sa bodega. Yung sulfur yung kulay yellow. Nakakita na kayo ng asupre. Yan, makikita niyo sa mercury drug. So, sulfur. You're familiar with sulfur? That's the yellow powder. You can, siguro kung nagka-alkal-kalkal kayo ng tinda ng mercury drug, makakita kayo ng sulfur. So, basically, sinusunog lang yon, it is reacted with air, and then you're going to produce sulfur trioxide. So, kung tandaan nyo pa yung Chicalt nyo, di ba? Ito yung isang reaction na binabalance natin. So, dalawa yung product niyan, I think, sulfur trioxide at saka sulfur dioxide upon combustion. Pero parang, if I remember it right, the dominant product is sulfur dioxide, Tapos merong reactant, merong reactor, So it converts sulfur dioxide to sulfur trioxide. Kasi sulfur trioxide yung nagre-react sa lab para maging labsa, linear alkyl benzene sulfonate. Ano? Yung linear alkyl benzene sulfonate, yun yung active ingredients ng Breeze, ng Tide, no? Ng mga detergent nyo. Ng Surf, ano bang ginagamit yung sabon sa bahay. Okay? So sabi dito sa slide, in order to convert sulfur dioxide to sulfur trioxide, we use a catalyst. So the catalyst is vanadium pentoxide. So yun. So dadaan lamang yung gas yan yung SO2, dun sa reactor na mayroong vanadium pentoxide. Tapos na ba kayo ng chemical reaction engineering? Hindi pa, ano? Yan. So gagamit kayo ng PBR. PBR is packed bed reactors, kasi may catalyst. Tapos kita nyo, yung production ng SO3, appreciable daw siya, significant, appreciable means significant, o nagkakaroon at 300 degrees Celsius. Taas taas ang temperature. So, pag 520 degrees Celsius, 90% yung conversion at equilibrium. Tapos, kita nyo, bumababa siya. At 680, 50% na lang. So, hindi straightforward yung ating temperature data regarding equilibrium. Merong temperature na mataas siya tapos biglang bumababa. So, kita nyo, merong optimum temperature. So in designing processes, we consider both the equilibrium and the rate. Magkaiba yun, magkaiba yung equilibrium at saka rate of reaction. Yung equilibrium, alam niyo naman yun, yung hindi na nagbabago yung concentration. Yung equal na yung forward at saka yung backward ng reaction, di ba? Yun yung equilibrium. Pero pag sinabi mong yung rate, yan yung bilis ng reaction, kung gaano ba katagal. Halimbawa, nagtitimpla kayo ng Milo, tapos malamig yung tubig nyo. Diba, pag nilagay nyo yung, titimpla ba kayo ng Milo? Inom pa ba kayo ng Milo? Pero once upon a time, siguro nagtitimpla naman kayo. Pag nilagay nyo yung Milo, diba, hindi naman agad siya natutunaw. No? So, medyo matagal nyo siyang hahaluin. Unless, alam nyo yung technique, yung nilalagay sa shaker, sa shake, mas mabilis yun. Pero kung halimbawa halo lang, medyo matagal. So, yung pagkatunaw ng Milo, ang tawag doon is the rate. Yun yung rate ng reaction, no? Yung pagkatunaw, yung time it takes bago matunaw yung Milo, that's the rate of the reaction. Yung equilibrium naman, kasi eventually matutunaw din naman siya sa tubig, no? Kaya lang it takes some time, no? Yung pagtunaw na yung Milo, that's the equilibrium part, no? So, I hope you can recognize between the concept of equilibrium and rate. Magkaiba silang dalawa. Yung rate yun yung bilis. Yung equilibrium naman, ano ba yung mangyayari at the end? Ganon. No? Kumbaga, yung rate, yun yung pag nanonood kayo ng sine, nakikita nyo kung ano yung mga dialogues. Pero yung equilibrium, ano ba yung naging ending? Ganon yun. No? So, in designing processes, we consider both the equilibrium and the rate. So, usually, tinitingnan natin, aabot ba talaga to in the end? No, itong temperature na to, itong pressure na to, aabot ba to? No? Makukuha ba natin yung product natin in the end? Tapos yung rate, mabilis ba yung reaction? Practical ba? Kasi pag sobrang bagal, maaabot nga niya yung product pero it will take, albawa, 1 year o kaya 100 years, hindi naman practical, di ba? Ganon. So we both consider the equilibrium and the rate. Pero alam niyo naman to sa kung nakapag 171 na kayo, chemical reaction engineering, yung reactor design is generally based on the reaction rate. No? Hindi naman natin kino-consider pag nagka-calculate na tayo kung chine-check lang natin. In equilibrium may product na dito, possible na ma-attain natin yung ganitong product. Chine-check lang natin, Pero hindi involved yung equilibrium sa calculation. So actually yung equilibrium is more of a chemistry thing, Pero yung choice of condition, halimbawa yung operating temperature, yung operating pressure, na usually sa 171, ina-assume natin na ito na yon, gagamitin na lang natin, based yun sa equilibrium. Ganun yung istorya. No? So, bago tayo mag-calculate ng volume using the reaction rate, pinipili mo natin yung temperature at saka pressure na based sa equilibrium. Okay? Ganun yung ganun yung istorya. So we'll try to explore some unique calculation in this chapter. Alam niyo na naman ang istorya nitong CHE124. Ano? Dati naman kasi wala tong CHE124. This is a relatively new course. So inintroduce lang actually ito sa inyo. Usually ang undergraduate thermodynamics is hanggang chapter lang. Siguro pinakamalayo na yung chapter 11. Hindi, chapter 10 lang. Pwedeng maabot yung 11. Kung tandaan niyo pa yung 11, yung nagka-calculate tayo ng volume ng pure substances na pinag-ahalo para ma-calculate yung solution. Yun, hanggang dun lang. Yun yung pinakamalayo. Pero ngayon, nasa na tayo, chapter 13. So, bago tong solution thermodynamics. Dati naman talaga walang solution thermodynamics. So that's why we're trying to explore yung mga calculation technique dito. So, reviewin lang natin yung concept ng stoichiometric number. This is the same as stoichiometric coefficient, no? The stoichiometric number, yung B, kung tandaan nyo pa, yan din yung symbol sa Yan din yung symbol ng stoichiometric coefficient. So for example, we have this general chemical reaction, So B1 A1 plus B2 A2, tapos so on, and then your product is B3 A3 plus B4 A4 and so on. So B sub I is a stoichiometric coefficient and A sub I stand for chemical formula. So the symbol B sub I itself is called stoichiometric number. So parehas lang yun, yung stoichiometric number at saka stoichiometric coefficient. So nilagyan lamang ng absolute value. May absolute value lang yung stoichiometric coefficient. Kasi yung stoichiometric coefficient palagi siyang positive. So ganun lang yung sinasabi ni Vanessa. Yung stoichiometric number, pwede siyang maging positive, pwede siyang maging negative. Okay? So positive siya pag product at saka negative siya for reactant. Yung kung nakapag-Aspen-Hysis na kayo, meron na ba nakapag-Aspen-Hysis na dito? So sa Aspen-Hysis, pag magpapasok kayo ng reaction, ginagamit itong stoichiometric number, no? So pag i-input niyo yung reaction, pag yung reactant siya, negative yung kanyang stoichiometric coefficient. Magpapasok kayo ng balance reaction, negative yung kanyang stoichiometric coefficient. Pag naman product yung chemical, positive yung kanyang stoichiometric coefficient. So ang tawag doon ay stoichiometric number. Okay? Meron na ba sa inyong Aspen-Hysis, com-apps? May nagko-com-apps ba ngayon? Wala pa, no? Parang 134P kasi ata yung Yun, may ang Aspen-Hysis kasi yun yung ginagamit sa pag nakapasok kayo sa mga design companies. Yun yung ginagamit na software. Okay? Pang-cheming yun. Aspen-Hysis. So, for example, for the reaction, methane, CH4 plus H2O will produce your carbon monoxide and 3 moles of hydrogen. Okay? So, ang stoichiometric coefficient for CH4, stoichiometric number is -1. Stoichiometric number of water is -1. Okay? Stoichiometric number of carbon monoxide is 1. And the stoichiometric coefficient of hydrogen is 3. Nasundan nyo? Nakita nyo kung paano? Yung how to determine the stoichiometric number? Dali lang naman, di ba? So basically, ito lang naman yan. Itong 3 na to, yun yung stoichiometric number ng hydrogen. Ito kasi walang nakasulat, so ibig sabihin may 1 yun dyan. So that's why, yung sa carbon monoxide, 1. No? Yun lang. Pag reactant, -1 yan. Kasi reactant yung methane. So that's why yung methane, kita nyo, -1. Ganun din sa water. Reactant din yan, kaya -1 din. No? Do you have any question regarding stoichiometric number? Kung wala, let's proceed. Okay, let me introduce the concept of reaction coordinate epsilon. So, yun namang reaction coordinate epsilon as the reaction represented by equation 13.1 progresses, the changes in the numbers of moles of species present are in direct proportion to the stoichiometric numbers. No, thus for the if 0.5 mole of methane disappears, now by reaction 0.5 mole of water also appears. So, di ba, we have this reaction na CH4 plus H2O. Tapos ang product natin ay CO at saka hydrogen, ano? Tatlong hydrogen. So ang sinasabi dito, pag daw nawala yung 0.5 mole of CH4 by reaction, it disappear, no? Mawawala din yung 0.5 mole of water. Kasi 1:1 sila, di ba? Okay? So simultaneously, may mag-a-appear na 0.5 mole of CO at saka 1.5 mole of hydrogen. So magkakaroon din ng 0.5 nito, tapos 1.5 nito, kalahati. Ano? So applied to differential amount of reaction, this principle provides the equation DN2. Halimbawa yung 1, ito yung methane. Itong 2 yung water. Parang sinasabi lang niyan, di ba yung 0.5 divided by 1 is equal to 0.5 divided by 1. It's obviously is true. So ganun din sa product, ano? So sa product naman, halimbawa 0.5, di ba yung B3 natin is 1. So this is negative. 0.5 is 1. Ito yung sa CO, ano? Tapos yung sa ano naman is 1.5 divided by 3. Di ba? 1.5 divided by 3 is also 0.5 divided by 1. Right? So, ganito yung sinasabi nitong equations na to. Ano? So, the list continues to include all species. Comparison of this equation yields, I guess, itong inequal niya dito, kasi hindi naman talaga equal kasi may negative. Ano? Probably, yung puro reactant to. Tapos, no? Puro reactant. So, all terms being equal, they can be identified collectively by a single quantity representing an amount of reaction. That's a definition of dE. So dE is the derivative of the reaction coordinate, or d epsilon. So this is given by the equation dN1 B1 is equals to dN2 B2 is equals to d epsilon. Question? Do you have any question? So although yung ating proof ay inductive, no? Okay lang naman sa inyo, no? Hindi naman tayo mga math majors. So do you have any question regarding the justification of the reaction of dE, d epsilon? Okay lang? Do you have any question? So let's proceed. Let's integrate this equation. So now, ang ginawa ko from this equation, di ba? We have dNi bi, no? And then this is equals to dE, d epsilon. So I assume this is constant, so tinransfer sa kabila. Ito na siya, ano? Tapos we integrate this from initial number of moles, NiO. NiO is the initial number of moles to the final number of moles n sub I. No? Tapos ito naman from 0 to epsilon. No? So pag in-integrate nyo to, you're going to have n sub I minus n sub IO. Imagine nyo ba? Is equals to b sub I d epsilon. Ito yung lalabas. Di ba? Pag in-integrate nyo to. So pag tinranspose nyo yung n sub IO sa kabilang side, you will have n sub I is equals to n sub IO plus bi epsilon. Do you have any question regarding this? Okay, so if you don't have any question, let's proceed. Yung summation, let summation of n sub I, yung initial number of moles, or yung number of moles be equal to n. That's the total number of moles, at equilibrium. So summation of n sub I. So yung summation of n sub I from this equation, summation of n sub I is equal to summation of n sub IO. Tapos constant naman kasi yung given naman tong epsilon, you can take this out of the equation, then summation of b sub I. Okay, so then if you're going to simplify this, so n this is the initial, ano? This is the initial. Ito yung ito yung sa species. Ano ito yung sa species? Ito yung total. No, ito yung total. Summation of B sub I is equals to B. Tapos summation of N sub I is equals to N sub O. Where summation of N sub I is equals to N. Summation of N sub O is equals to N sub I O. Ito yung initial number of moles. Ito yung at equilibrium. No? Ito yung initial, ito yung at equilibrium. So ito yung N sub O, ito yung total of number of moles sa initial, ito yung at equilibrium. Ganun yun, ano? Tapos yung B naman is the summation of B sub I. Ang summation of B, ang B sub I naman hindi nagbabago kasi isa lang yung chemical reaction natin, di ba? Kung ano yung so initial at saka final, hindi naman nagbabago yung B. So that's why wala tayong final at saka initial. Pero yung number of moles nagbabago yan during the course of the reaction. So kaya meron tayong initial at saka meron tayong final. So ang mahalaga dito is we need to calculate the mole fraction of Y sub I. So the mole fraction of Y sub I is N sub I divided by N. Tama? N sub I, this is halimbawa, number of moles of methane. Yung N, the total number of moles. Ganun yun. Ano? Di ba? Ito yung mole fraction, N sub I divided by N. Ngayon yung N, di ba we have derived that N is equals to N sub O. Remember, N sub O is the total number of of moles. N sub O at equilibrium. Ito pala yung at equilibrium. Plus B times E. Ayun. Tapos ito yung sa ito yung sa methane lang, yung number of moles of methane. At tapos ito yung B sub I ng methane. These are all in equilibrium. Siyempre, in equilibrium to lahat. Na-imagine nyo? So, halimbawa, meron kayong 0.5 mole na lang ng methane. Ito yung 0.5. Ito yung B sub I, ito yung 1. Tapos yung epsilon, halimbawa, given siya na 0.5. Kung ano yung given na, na epsilon value. Ito yung total. Yung N sub O, yung total. Halimbawa, yung number of moles ng methane, number of moles ng water, plus yung number of moles ng carbon monoxide plus yung number of moles ng hydrogen. Yan yung N sub O. Itong B, yan yung yung halimbawa, 'di ba? 1 for CH4, no? 1 for water, negative 1 for water, negative 1 for CH4, and then positive 1 for CO plus 3 for H2. Yan yung B. Ganon, So that's one way to calculate Y sub I using the epsilon. So tingnan natin yung madali lang to, huwag kayong mali to, madali lang. So tingnan natin yung problem, example 13.1. For a system in which the following reaction occurs, ayun, ito pa rin yung example natin, methane plus water becoming carbon monoxide plus 3 moles of hydrogen. Assume that there are present initially 2 moles of CH4, 1 mole of H2O, 1 mole of CO, and 4 moles of H2. Determine the expression for the mole fraction of Y sub I as functions of epsilon. So, ang formula lang natin dito ay Y sub I is equals to NiO plus B sub I epsilon divided by NO plus B epsilon. Yun lang yun, So, determine nyo lang muna yung ito kasi yung N sub I, madali lang yan. Ito lang yan, Ito lang yan, yung 2. Yun yung 2 ng, halimbawa CH4, halimbawa, we want to determine YCHO. So, ito lang 2 yan. So, 2. Tapos yung B sub I naman, tingnan nyo lamang yung reaction. Di ba may negative 1 dyan? So, may negative 1 epsilon. Okay? Tapos yung baba, yung N sub O, kailangan i-add nyo lahat yung number of moles. So for example, yung N sub O ay 2 plus 1 plus 1 plus 4. Ilan to? 8. So 8 ito. Tapos yung namang yung D, ito yung sum nila. Ano? Yung sum nito, negative 1, negative 1, positive 1, positive 3. So, 3 plus 1, ito yung B. Ano? 3 plus 1, 3 plus 1, minus 1, minus 1. So, ilan to? Kakancel to, 2. Okay? So, and of course, you need to do this for water, for carbon monoxide, for hydrogen. Do you have any question regarding regarding how to solve this type of problem? Bali, nahanap lang yung Y sub I, YCH4, YH2O, YCO, YH2. Yung nasa taas, yung sa specific, diba, sa methane, no? Yung nasa taas. Yung nasa baba, yung total. So that's why you need to perform these operations. Gets nyo? Ayan, ano? So ito yung sa CH4. 2 minus E, H plus 2E. So gagawin nyo lang muna, yung B muna i-add nyo. Yung B, minus 1, plus 1, plus 3. So 2. Okay? Tapos yung NO naman, yung given na NO. 2 plus 1, plus 1, plus 4, 8. So yun yung nasa ilalim. Ito yun. 8 plus 2E. NO plus 2E. Tapos yung nasa taas naman, yung sa CH4. So sa CH4, yung kanyang number of moles is given as 2. Ito yun, di ba? Yun. Gets? Tapos yung negative 1 dito, galing yun doon. Doon sa reaction, sa chemical reaction. Nakuha? So for example, sa water. So sa taas muna. Yung water, given na 1 mole yung water, di ba? Ito yun. Tapos negative 1 din siya. Ito yun. Tapos kita nyo, yung denominator, hindi nagbabago yan. Lahat ng denominator hindi nagbabago. So hindi magbabago lahat ng denominator. No? Do you have any questions? Yung nagbabago lang yung sa taas. Kasi pag water yung gagamitin nyo. Halimbawa, hydrogen. So yung hydrogen, kita nyo itong unique na number na 3 na to? So siya yung nandoon. Diba? Siya yung nandoon. Kita nyo? And then, 4 yung given na hydrogen. Do you have any question regarding this? So pag may value ng epsilon, you can calculate the mole fraction. Do you have any question regarding this problem? Okay. Kung wala, let's proceed. Let's try to solve 13.2, example 13.2. Consider a vessel which initially contains NO mole of water. Ilang minutes na ba? 2 minutes. Basically, ganun din to, ano? So, consider a vessel which initially contains only NO mole of water vapor. So, walang hydrogen, walang oxygen. Water lang, NO. If the composition occurs according to the following reaction, H2O becomes hydrogen and oxygen, 1/2 oxygen. No? Find expression which relates the number of moles and the mole fraction of each chemical species to the reaction coordinate epsilon. So, halimbawa, YH2O. Do you calculate YH2O? Just use the same formula. Ano? N sub IO plus B sub I epsilon divided by NO plus B epsilon. So, calculate nyo muna yung N sub O. Ano yung N sub O? Ito lang, di ba? NO. NO din yan. Tapos, kasi N sub O mole of water. Tapos yung ano, yung B. Yung B, negative 1 plus 1 plus 1/2. So magka-cancel to, B is 1/2. Ganun lang, ano? Tapos ano, substitute nyo na, YH2O, ano yung initial number of moles of water, di ba? N sub O. Tapos B sub I, negative 1, epsilon. Tapos, anong denominator natin? N sub O and 1/2. Okay? Do you have any question? And so on. Gawin na lang yung iba. Ano? So, ito yan. Ano? YH2O. This one. Diba? So matatapos na yung time natin, you need to do this, ano? So i-open ko to sa, actually naka-open na ata, ano? Naka-open na to. Tapos I'm going to provide another link ng Zoom. So try to solve this problem. Nasolve niyo na ba to? Actually available na to sa ano? Available na to sa BBL. So I'm going to stop this. Tapos I will provide another link. Ha? I will provide, please connect.